Right, hi, I'm Alan Zimmerman. I work for WhatsApp. I work on developer infrastructure, in particular on the Erlang language platform, ELP, as we all know it. Just before I get started, as a matter of interest, how many people have heard of it? Okay, well, that's encouraging. How many of you actually use it? Okay, less, but give it a try. It's worth having. It's on VS Code. It's kind of in Emacs for LSP mode. It's in NeoVim, so give it a try. Okay. ELP is an engine. It's a language server, but it's also a way to add diagnostics. You can... Sorry, let me just move on to the next verse. Let me just talk about what ELP is for our context. I'm going to talk about adding diagnostics, but first let's just talk about where we are in the thing. So ELP manages context. Context is, especially if you're in developer tooling, you struggle a lot with context. If you're a user, you just take it for granted. So the kind of context I'm talking about is, what kind of project are we looking at? Is it a rebar project? At WhatsApp, we use Buck. Is it a Buck project? Is it OTP that uses its own custom makefile? What does this project look like? How do we know what's in it? How do we know how to compile it? How to put the pieces together? So that's one of the things that ELP does. That's the going down. Then the kind of going up side of it is it's no good having all of this stuff if people can't see it. So that's where showing it up in your IDE. As I said, it's in VS Code, it's in Erlang, it's in NeoVim, it's in kind of anything that can do it. It's also available, you can use it on a command line if you're in a constrained circumstances. It can emit JSON output, so if you want to use it in your CI pipelines, you can do that as well. And then if you're writing tools, if you want to write a new diagnostic or a new lint or whatever, then you need information, and ELP manages information. It does, I call it code intelligence. This is not AI. It kind of synthesizes information. It uses the output from the normal Erlang compiler. We have our own internal parser that is more amenable to the sort of IDE use case. It can deal with broken code and still give you output and all the rest of it. We have equalizer built in. We can get the output of common test. We can get the output of edoc, which is going away, thank heavens. I mean, shall we say it's moving to a more manageable, tooling-friendly environment. And the other thing is, it's available to you in a lot of contexts. You can just have it on your machine quite easily. So that lets you, if you're a tooling developer, if you want to add functionality to it, all of the stuff you need is right there. You can just get on with it. So now diagnostics, diagnostic lint, they're kind of the same thing. It's when your tool notices something about the code that you want to bring to the attention of the developer and potentially do something about it. The diagnostics are normally the things built into the compiler. Those are things like, you've missed, this code just doesn't make sense, we can't compile it. Lints tend to be more like, there's a better way of doing this, maybe you should consider something else, or this is bad style, or whatever. But internally, they kind of pretty much follow the same path inside. So I'm going to talk about diagnostics, but it applies to lints as well. One of the things that we do in ELP is we give a diagnostic code to every single, we give an error ID, an error index ID to every single diagnostic we generate. So for example, that L1230 means unused function. It comes out of the Erlang compiler. If we want to not have this thing reported to us because we want our overall compile to be clean, but for some reason this function is in fact used, then we just put either a fix me or an ignore comment on it, and then it's not going to be reported. We can also use these error index IDs in a config file, so we can say, right, when we run this particular CI pipeline, we want to report on these ones only, and we specifically don't want to report on that one. Every one of those has a page on this error index. It's been accepted as a standard, EEP 74. The details are still being worked out, but kind of the concept of having every single tool in the Erlang ecosystem, the Beam ecosystem, generate these error index tags, which then each one will have its own web page. They can be searched for. They become a kind of a tag for your overall context. Each one has a web page. They kind of, the more you use them, the more useful they become. It becomes a shorthand to refer to a particular problem. It makes searching easier, more targeted. The community version is still being standardized and rolled out. In the meantime, we have a version at our website, which you can access from there. And you'll see how we use them as we go along. This is what an actual diagnostic looks like, going down into the weeds. First thing you'll notice is that's Rust. ELP is written in Rust. There's various reasons for that, but it is what it is. To just give you an idea, if you want to report a problem in code, that is the vehicle that you use to report it with, and it has a number of things that need to be in it. This is a struct. It's very similar to a record in Erlang. So essentially, you first need to say where it is. This thing belongs to a file. It has a location, which is a range. You give it a message that which is what you present to the user, saying, this function is undefined or whatever. Your severity, you say it's a weak warning or a warning, which has then got a yellow squiggle under it, or an error, which has got a red squiggle under it. Is your severity. The diagnostic code, which you've just spoken about. It also has a URI that we can give it, and that generally points to the error index page, which is useful if it shows up, you're not sure what to do. The error index page will often say, if this thing comes up, this is why it comes up, and if this is how you can fix it. So it gives more context, so you can keep your specific diagnostic message more focused. It also has the ability to have fixes in it, which I'll explain a bit more later in the talk. Now, if you want to add one, there's a bit of admin you need to do. First of all, you obviously need to give it an error code, and there's a particular way that you give it an error code in the Rust code base. You need to make a function that you're going to call for this thing. You need to tell the code to call this function, and of course, you need to make this the error index documentation file. Now, it's a bit of a pain to do that stuff. It's easy to look at the code and copy and paste. There's another way. You can use the modern mechanism. Point any random AI tool at it. In this particular one, we said add a new diagnostic using SSR, which I'll talk about now, to match for binary strings like that example and convert them into Erlang sigils like that. And I gave it, in this particular example, I gave them those two files, the diagnostic code file and an example other diagnostic file, and it chugs away and it generates all of the boilerplate that you need, and you end up with the part that you actually care about. Okay, first of all, sorry, rewind. This diagnostic actually exists. It's in the latest version, which you can download install from the App Store, VS Code. You'll notice it's number W0051. It means it's we already have 51 of these in ELP, and they're quite easy to add. So hopefully at the end of it, you guys will add your own, and we'll soon hit 100. This is what it looks like. It says it's a weak warning because it's just a useful thing. It's not going to clutter up your view when you're working with it, and it's going to say, here we found a binary string. You can write it in sigil syntax if you want it. And this is what it looks like, if I can get it to run. Ah, damn it. Okay, I want you to imagine you're seeing an IDE and you've got some code and it shows up one of those and then it highlights up and you click on it, it's got a code action and it fixes it for you. I think I should have been on the internet. Okay, right, fantasy world over, back to reality. Okay, this is the heart of the thing. So once we've done all of that admin, all of the other admin, adding the diagnostic code and the call to it and the documentation, all the rest of it, it calls this function. And the first thing that happens is it's declarative. We have a descriptor, and the descriptor says, these are the conditions that we care about for this one. First of all, it's not experimental. You can, in the config of the IDE, you can say, do you want to see experimental stuff? On the command line, you can say, show me experimental stuff. If you want to put something out there and not annoy all of your co-developers, you mark it experimental, you get it working, and then you make it live. Generated code. At WhatsApp, we have a lot of generated code. We have a convention that we put a tag somewhere in the first 2,000 characters in a comment of @generated. If we see that, then we mark it as generated, and we can decide whether we want the lints to apply to it or not. Generally, you don't want to because there's nothing you can do about it, but sometimes you do. Tests, we separate out as well, because a lot of the time, test code is kind of nasty code in that it's setting up environments and scenarios that are not best practice, but you have to do it to get a test fixture into place. So you may or may not want to include it. And sometimes you want it disabled, so it just doesn't show up in the IDE, but if you put in a config file, then it can show up. So that's what that's for. And then you tell it a function to call, which takes a bunch of arguments, the list of diagnostics, a handle to like the analysis, the semantic analysis, and the file and the extension of the file so that you know what you're working with. So that kind of sets the stage. That thing, once you've done all of the boilerplate, that thing's going to be called for every file that changes to check if this particular problem exists in it. And this is what the actual checker looks like. It's also a lot of code, but it's not that much code, and it's also fairly declarative. The first thing we do is we call a function that matches the pattern in the file function. So we're going to, in the file, if it has functions, we're going to match over these functions. And we have a strategy there. Now, ELP does not have a separate preprocessor stage for macros. So we expand macros, but we keep track of where the expansion happened. And when we track over our code, we can either, depending on what we're trying to analyze, we may want to look inside the macros and see the code in there. We may want to just stay on this, at the surface level. We may want to look inside and know that we've gone into the macro. In this particular case, it makes sense not to expand the macros because we're working at the surface level of what you've written. That means we're going to process the arguments to the macros, but not the macro body itself. Similar with parentheses, you can make them visible or not. It depends. If you're doing something that cares about parentheses, you're going to want to see them, otherwise not. That SSR thing, don't worry about it now. I'll talk about it next. And essentially, that's going to go through your file, all of the functions in it. If this thing matches, for every match, it's going to call a function to make a diagnostic. And that's kind of the heart of the thing. So the descriptor tells you where it must be, and this thing is going to do go and do the heavy lifting of finding it for you. That SSR, it stands for Structural Search and Replace. It's something that existed in, ELP is based on Rust Analyzer. We share a heritage on it. It exists in there. So far, structural says it matches the structure of your code. So instead of just matching kind of line by line, it looks at the actual AST. We have an internal AST inside ELP called HR, it's a horrible name. But essentially, it's like abstract forms. But we also, inside it, we've resolved all function calls and types, and we have scope resolution, and there's a whole lot of extra information for it. We can tie it back to equalizer types as well if we need it. And then the search is obvious, it's going to search through it. The Rust one does replace automatically. We have to do it slightly more, do it by hand, but that's roughly what it does. Just to give you an idea of the structural stuff, this is a tool called Difftastic. Difftastic uses a tree setter grammar underneath. The Erlang one actually uses the tree setter grammar that we wrote for ELP, and it does a structural comparison. So this is a diff, it's JavaScript code. The first block, foo baz, has been wrapped in a conditional, and the argument to the bar has changed. So you'll see on the right-hand side, it highlights just the things that have changed. So even though the code is moved around and is kind of in different places, it knows that these are the only things that have changed. In the second one, you've got a list, an item's been added to the list, the whole thing's been reformatted to fit, but it highlights that just Yvonne has been added. So that's the kind of that's what this search does. So if you're using a grep, if you're using a regular expression, which is a standard way of writing lint, then you've got to somehow try and match what you see and make sure it's on one line only and there's comments and all the rest of it. This kind of matching, it doesn't care about comments, it doesn't care about layouts, it's going to look for the actual thing that you care about in terms of code. This is the actual SSR side. So this is what we're doing. It says the SSR colon and the full stop is just kind of boilerplate saying what it is. Here we're saying we're looking for a binary. We have a variable inside it. We've stolen the Merle syntax. So the underscore at says this is a placeholder that we're looking for. So that's going to match any single item that occurs in the binary syntax. The second example there says we're looking for a tuple of 2 elements. The first one needs to be the atom OK, and the second one can be anything. So it'll match it OK4, and it'll bind val to 4, or it'll match the second one, and it'll bind val to length 1 to 3. So once you've done the match, you can then, for each match, you can look at the placeholders in it and do stuff with it, which makes for very, very simple matching of things that you're searching for. One other wrinkle or feature, if you put the same placeholder name, it's going to match the same item. So it'll match the first one where we've got OK, it's not going to match OK and other. So if you're saying, if I'm looking for this thing here and it appears over there as well, then you can match it this way. And so this is just going back to our original piece of code. That's the SSR match in it. So that's what this whole thing's doing. It's matching using that SSR, and then it's going to call make diagnostic when it finds the match. When you get the match, we say, give us the text of the match. If it starts and ends with a double quote, then we know we've got a string, and we make a diagnostic with that binary, the diagnostic code we asked for, and we give it, we say it can be rewritten. We say it's a weak warning, so it's just going to show up in a just very, it's not going to be emphasized in your IDE, but you'll be able to see it, and you can put those ELP ignores or ELP fix me's on it. And that's all it takes. There you go. That is your diagnostic written. You can publish it and make a pull request, and we're good to go. So if you want to match anything, that's what you do. If you want to make changes, we've got this thing called a builder. Here we're basically saying, for the range that we matched, replace it with that string over there. That format says, put a tilde and then take the thing that we matched, that matches text, and put it in there, and it's going to do it for the range. And then in that first part where we're making the diagnostic, we just add the, with fixes at the end, add that fix in it, and that's got a fix on it. And now this one you can actually see. This is calling it from the command line. Exactly the same. This is actually calling it inside one of the test projects on the ELP repository, so you can run it at home if you want. We say we're running it in rebar mode. We're doing diagnostic filter of this W0051, which is the diagnostic code we gave it. We're applying a fix in place. So it goes off, it finds it, and then it makes a diff. This here is the change it's going to do. And that's it. That's at finding something you want to change and changing it, and that's the only code you have to write to get it to happen. Inspiration. This is the Inarco Erlang guidelines. I'm pretty much sure most of those could very easily be turned into diagnostics using this technique. So if any of you want to jump in and pay attention, do it. We're available. If you have questions, you can ask on there's an ELP channel in the Erlang Slack. And if you just file issues on the repository, we'll respond to them as well. And be only too happy to help anyone want to try it. It does mean writing Rust. Yeah? There's the caveat, which is probably a good thing to have in your CV anyway. Right, and that's where the project lives. Thanks all. Any questions?
Questions? Oh, wait. Oui.
I actually have a few, but I will ask for one now, and the rest I will pick up outside. What's the process of deciding what rules will end up in ELP and which ones will not?
Essentially, if you make a pull request and the thing is sane, then we will merge it. Because it is configured, because everything has a unique diagnostic code, it's configurable. So we don't necessarily, it's up to you to enable or disable particular ones. So we'd rather have more in the code base than fewer. And because we have diagnostic codes as this sort of way of managing these things in every location, it means we can easily configure the ones that we want to see and also configure the ones we don't want to see. What I personally would like to see one day is a way of kind of easily configuring these kind of just without actually writing code at all. But there's still some work to be done. But yeah, there's no reason, each individual location can choose which ones they want to have enabled or not.
Yes, thank you, Alan. Yeah, so Alan give you a tutorial how to, write those. Yeah, so his nudge, please.